there anyone who would like to tell us how you approach the question? Joseph, how did you do it? Yes, cake. Sorry? Okay. Okay, so we have A, B, C, D. And we have A, B, D, E, A, B, D, E. So it will be that one. Okay? We are supposed to prove that B, C, E, F, which will be this big one here. We're supposed to prove that that's a palm. Okay? Well, first thing, you have to know your properties of the palm and their converses. As I told you yesterday, I'm going to repeat it again. There are only 5 ways that you can use to prove that a quad is a palm. 1, you have got 2 pairs of opposite sides that are equal, 2 pairs of opposite sides that are parallel. You have got diagonals that bisect. You can also prove by saying that a pair of opposite sides are equal and parallel. Okay? Those are the main ones. Right? So if you don't know your properties of a palm, then you might have some issues. You prove that a quad, you can only prove that a quad is a palm by using the properties. If you don't know your properties of a palm, then you are going to have major problems. Okay, so here we are given that BD is equal to DF. Okay, now this is how I'm going to do it. If I can prove that ED is equal to DC, then I'm done with the question. Okay? Because already I'm told that BD is equal to DF. Okay? So the objective for me, I don't know how you did it, is to prove that ED is equal to DC. And for this question, it's very easy to prove that ED is equal to DC. Okay? So I'm going to start by saying, right, DF is equal to DB. This is given. Okay? That's provided in the question. Please do me a favor. I need your maximum attention. I need your maximum attention. Don't look down like this. Right? So I'm going to say CD is equal to AB. Okay? There isn't opposite side of a palm. Yes, because I'm told that ABCD is a palm. Okay? AB, I'm sure you can see that AB is a common side for both palms that are given. Okay? It's a common side for both palms that are given. What that means is this length here, CD is equal to AB and AB is equal to ED. Okay? So let's carry on. And then I'll say, since I've got CD equal to AB, I'm going to say ED is equal to AB. And my reason is the same. This is opposite side. Okay? Now, because of this, it means I can say, therefore, CD is equal to ED. Okay? We have AB appearing in both statements. on the right hand side. Therefore, I can equate these two statements here, and you can eliminate AB. Okay? So we can end up having, say, therefore, CD is equal to ED. I don't have to give a reason for that. It's a deduction from these two statements. Okay? All right. Then from here now, I'm going to use the fact that DF is equal to DB, that's given. I prove that CD is equal to ED. What that means is the diagonals of that part, they bisect. Because they bisect, therefore, I can call it a palm. Okay. So I'll say, therefore, BCFE is a palm. My reason, right, it will be converse. By converse, we are saying the original property of the palm is that the opposite side, the diagonals bisect. Now we are saying if the diagonals bisect, it therefore means that the quad is a palm. So we have to put the word converse. Okay? The word converse means an opposite statement. Okay? An opposite statement or a reverse statement. So this would be converse diags of a palm. You want, you can put diags of a palm bisect if you want. But based on the acceptable reason that I gave you, that's how you can write it. Okay. To prove that a quad is a palm, we use the converses of the theorem. When it comes to the diagonals of a palm bisect, that's the theorem. The converse, if the diagonals of a palm bisect, it therefore means that the quad is, or rather, if the diagonals of a quad bisect each other, it therefore means the quad is a palm. That's what's happening. Okay. Any question? I think the question itself, you might have to figure out probably if there's a second way of doing it. Okay, but this is how I would approach it. All right. Any question?